What springs into your mind when you hear someone say the words black hole? Don't think about it, just say the first thing that comes to your brain: space, stars, universe. How about mysterious or dangerous or yawning abyss of doom? Now think of the last film or TV show you saw that featured a black hole. These are the heroes we're trying to escape from, its remorseless grasp, or maybe the black hole was distorting time in some weird and chaotic way. Well, you see, the reputation of black holes as objects of mystery and dread persists. It could be an all-consuming devil or a physics-defying trickster god, but this hasn't stopped us from being fascinated with them. To many people, black holes evoke a mysterious darkness threatening to swallow you up. To scientists, they have sometimes seemed like the mystery that might swallow physics. They awkwardly bridge the theories of quantum mechanics and general relativity, exposing deep weaknesses in our understanding of nature. But recent theoretical and observational advances have helped illuminate these shadowy objects with profound implications for more than just black holes themselves. And in a world-shattering revelation, scientists just declared that the gluttonous monsters may hold the mind-bending secrets of the early universe, redefining astronomy. Join us today as we dig deep into how weird black holes could lift the veil of mystery of our universe. As far back as we've been able to crane our necks, our civilization has been looking to the stars with a sense of wonder and awe. Our earliest ancestors worshipped the skies with fierce superstition, and on the darkest of nights in the quiet of a countryside away from the light pollution that plagues our towns and cities, it's easy to see why our heavens hold a beauty that is unparalleled anywhere else in the natural world. It wasn't long before our ancestors started applying the rigor of mathematics to the sky. Astronomy is, in fact, the oldest of the natural sciences, dating back to prehistoric times. The Babylonians, the ancient Chinese, the Greek philosophers, the Egyptian pharaohs, all standing on the shore of an endless ocean of light underneath dark skies with bright and starry eyes, meticulously studying the mechanics of celestial bodies far beyond their comprehension, watching with a sense of wonder as points of light danced above them in the night. Today, our knowledge of the universe has surpassed the wildest hopes and dreams of those who came before us. We know that some of those points of light are actually giant nuclear fusion reactors called stars, just like our own sun. And some of them are galaxies so far that our eyes reduce them to a collection of billions of stars to one single point. We know how stars are born and how they die, and that if a star is big enough, when that time comes, it will collapse in on itself to form a singularity, an object so dense that not even light can escape its gravitational pull. We call these objects black holes. Black holes are the most mysterious objects in the universe. They're places where physics is pushed to its most extreme, where light cannot escape, and where space-time itself is twisted and even punctured, leading to the most incredible and counterintuitive phenomena. So it's easy to see why black holes have such a fearsome reputation. They're not exactly the ideal destination for your holidays. If you were to approach a black hole, you may notice a disk of glowing material around it. Gas and other material can get pulled into orbit around a black hole. This produces friction, which creates light and heat. We call this an accretion disk. The temperature of an accretion disk can reach millions of degrees Celsius. As a result, it gives off lots of high-energy X-rays. This helps scientists detect black holes, but it also means that approaching a black hole could be hazardous to your health. If you survive the temperature and radiation from the accretion disk, things would get even weirder. Just outside the event horizon of some black holes is an area called the photon sphere. In the photon sphere, gravity is strong enough to bend light around the black hole. In theory, light could reflect off the back of your head, orbit the black hole, and then hit your eyes while you would pass the event horizon, staring at the back of your own head. Yeesh. Once you're past the event horizon, things would get really grim from there. If you were heading towards the center of the black hole feet first, the gravitational pull on your feet would be a lot stronger than the gravitational pull on your head. You'd get stretched and squished like spaghetti. This process has been named coincidentally spaghettification by scientists. This all sounds pretty scary, but don't panic. We are in absolutely no danger from black holes. They're a bit like tigers. It's a bad idea to stick your head in their mouth, but you're probably not going to meet one on your way to the shops. Unlike tigers, however, black holes don't hunt. They're not roaming around space eating stars and planets. There is no black hole near our solar system, so there is no chance of Earth ever getting sucked into a black hole. In fact, the closest black hole to Earth is 1,560 light-years away from us. It would take around 30 million years to travel there in a rocket. But what if our sun turned into a black hole? Well, the good news is our sun is not a big enough star for that to happen. And even if a black hole took the place of our sun, Earth wouldn't get sucked in. If the black hole was the same mass as the sun, then it would have the same gravity as the sun. Earth and all the other planets of our solar system would stay in the same orbit. We'd be walking around in the dark and we'd be very cold, but we wouldn't be squished into spaghetti. Although we may not be in immediate danger from them, it seems as if we're right to be at least a bit wary of black holes. But if we think of black holes only as terrifying orbs of death, we're missing out on all the truly exciting things about them. The first one, our galaxy's heart is such a gluttonous monster, like the mythical Kamipa of the Sotho people of southern Africa. The Milky Way's central supermassive black hole has swallowed nearly everything around it, growing heftier and heftier the more it eats. And it's not alone. Black holes weighing as much as thousands, millions, or even billions of suns sit at the center of nearly all known massive galaxies. For decades, scientists thought that was the only place they'd find such behemoths, because only massive galaxies had enough material to feed the monster's excessive appetites. But beginning about 2 decades ago, computer simulations of the earliest black holes started turning up oddities, big black holes that weren't smack dab where they were expected. These misfits must be nothing more than flukes, many scientists reasoned at the time, dismissing the results without a second thought. But others weren't so certain the oddballs should be cast off. If observations show that these unusual black holes exist in the nearby universe, these astrophysicists speculated, they could be untapped clues to the universe's infancy and adolescence. Like theoretical astrophysicist Gillian Bellaveri of Queensborough Community College in New York City says, we can weirdly learn about the super beginning of the universe by looking at things really close to us. The notion remained just an idea for years, but now the existence of these misfits isn't so easy to ignore. Astronomers have turned up signs of a number of unexpectedly massive black holes in the universe's tiniest galaxies, and surprisingly, some of those black holes don't appear to sit at their galaxy's centers. Even more intriguing, the astronomers have spotted evidence of black holes wandering at their galaxy's edges and, in rare cases, being kicked from their homes into intergalactic space. Perhaps these black holes aren't merely cosmic nonconformists, but instead big players in the story of our universe. If so, they are a tool for probing one of the greatest mysteries in all of astrophysics, how the cosmic comepas we see today came to be. Without understanding what black holes are doing, you cannot understand galaxy evolution, says Jiahui Fan, a cosmologist at the University of Arizona in Tucson, making it impossible to explain the landscape of the universe, he concluded. Our current understanding of how black holes get so big goes something like this. In the early universe, the cores of baby galaxies had baby black holes. Over time, galaxies grew, smashed into each other, and merged. As they did so, the galaxies took on gobs of new stars, gas, and dust. Meanwhile, the black holes in their centers merged and fed on all the new material. As a result, galaxies grew, and so did their central black holes. In this scenario, the black hole at the center of each galaxy should be around 1,000th of the mass of its galaxy. Not all of today's galaxies are as big as our Milky Way, some dwarf galaxies have only about a trillionth its mass. In order to have stayed so small, they must not have merged with many other galaxies. Each dwarf galaxy's black hole would likely have escaped merging with many other black holes. Then, by that logic, the black holes in dwarf galaxies should be runts or non-existent. But computer models in the late 2000s started to cast doubt on this logic. These models showed how massive black holes could have evolved over the history of the universe. Even the smallest galaxies, they showed, could have large black holes. And right away, some of those galaxies never grew or merged with any others. This left the galaxies small with big black holes for billions of years. Astronomer Amy Raines found the first hints that such galaxies exist more than a decade ago. She was looking through telescope data on a dwarf galaxy 30 million light-years from Earth. There she spied extreme amounts of radio light and bright X-rays. That intense radiation signaled the presence of a huge black hole. "I hadn't seen this before," recalls Raines, who now works at Montana State University in Bozeman. Like other scientists, she had assumed dwarf galaxies weren't big enough to have black holes. But a few months later, in 2011, Raines went to a meeting of scientists. There she heard astrophysicist Jillian Bellavary speak. Bellavary presented some new models of galaxy formation. These suggested that even scrawny galaxies could have hefty black holes. Raines was shocked to find her observations and Bellavary's models seemed to match. And not long after that, Raines launched an effort to find more dwarf galaxies with outsized black holes. She is part of a team that scanned roughly 25,000 dwarf galaxies. Of those, 151 seem to harbor a big black hole. The team shared its findings in 2013. If models like Bellavary's were right, the observed dwarf galaxies with big black holes most likely formed that way in the early universe. Since then they've been relatively untouched by mergers. If true, looking at these ancient relics might tell us something about the very first generation of black holes to exist. That includes those that eventually grew into today's supermassive monsters, such as the one at the center of the Milky Way. For instance, the mass of a black hole in some dwarf galaxy should be similar to the mass of some of the earliest black holes. So looking at black holes in dwarf galaxies could help astronomers figure out the starting mass of the original black holes. That, in turn, could help scientists tease out how those first black holes formed. Right now, there are two leading ideas for how the first black holes developed. Each idea creates black holes of different masses. The first idea has black holes forming as the first stars collapsed. This process would tend to create pretty lightweight black holes. The other idea, those first black holes could have formed from giant gas clouds that collapsed in on themselves. Those black holes should start out heavier. The dwarf galaxy that Raines observed seems to have a mass equal to a few million suns, and that's pretty heavy. It's one point in favor of the cloud collapse idea, but it's just one data point, and measuring the mass of black holes is not easy. Luckily, there are other clues scientists can use to learn how the first black holes formed. These hints come from an even odder type of black hole, massive ones that don't sit right at the centers of their dwarf galaxies. Remember Bellavary's computer models of the earliest black holes? Well, big black holes in scrawny galaxies weren't the only surprise her models turned up. Those models also suggested that some of those large black holes wandered near the edges of dwarf galaxies. "I always like to think about the outliers or the weird little rejects," says Bellavary. She's now based at Queensborough Community College in New York City. Bellavary reran her models. She zoomed in on the littlest galaxies. When she did, half of the massive black holes in dwarf galaxies would be off-center. She and her colleagues shared this finding in 2019. And as if on cue, a few months later, Raines had data to support those models. Her team's observations came from radio telescopes in New Mexico, known as the Very Large Array. The researchers peered at 111 dwarf galaxies. 13 most likely had big black holes, and of those 13, a few seemed to sit off-center from their galaxies' cores. Finding wanderers was a jackpot. Once a black hole starts wandering, it does not grow in mass anymore, says Marta Voluntari. This means stray black holes should match the starting masses of the first black holes even more closely than those at the centers of dwarf galaxies. Voluntari is an astrophysicist. She works for the Institute of Astrophysics in Paris, France. Sadly, weighing wandering black holes is even harder than weighing ones at their galaxies' cores. That makes it difficult to judge whether they match the star collapse or cloud collapse theory based on their weight. But the overall number of wanders can offer hints about how they were formed. If the earliest black holes formed from huge gas clouds collapsing, then wanderers should be pretty rare in dwarf galaxies. That's because converting a gas cloud into a black hole is quite hard, so that should make it a rare event, right? If black holes came from collapsing stars, though, they should be more common. The reason is that stars can collapse into black holes pretty easily. Signs of wanderers kept popping up, though, and that has researchers leaning away from the cloud collapse idea. But scientists don't just want to know how.